Hello friends, my name is Yash Baheti. I am a maths faculty at askIITians, and today we are going to start with the inequalities chapter. So inequalities chapter mainly consists of three types of inequalities. First is the very basic inequality, that is the linear inequalities. Second is the quadratic inequalities, and third is the final, that is logarithmic inequalities. So we'll first start with the linear inequalities. Now first topic is linear inequalities. Now what do we mean by first inequality? So inequality is any mathematical expression which is signed with a sign greater than or less than any value, or maybe another expression. For example, let's say that taking example of linear inequalities, let's say that if I say that x minus 3 is greater than 0. So I want x such that if I subtract 3 from it, the outcome must be greater than 0. So obviously the answer is that any value that is greater than 3, if you subtract 3 from it, then the outcome will be obviously greater than 0. So this is just an analysis based upon the expression. Now let's look about the mathematics part. How we can get it mathematically? What we can do, we can take this 3 on the right hand side, so it will become plus 3, so x greater than 3. Now x greater than 3, this answer or this expression defines a set. Which set is this? This set is 3 to infinity. The expression is saying that any number that is greater than 3, that will satisfy. So 3 to infinity. Now suppose that instead of this inequality, suppose that if there is this greater than or equal to, then what will happen? Then this 3 is also included. Then this 3 is also included. Why? Because if you put x equal to 3 here, then 3 minus 3 will come 0. So closed bracket, that means the value included. At the same time, open bracket, that means value not included. So this is the very basic thing. I hope that everybody understands this. Now let's move to some other form. Let's say that x minus 3 greater than x minus 2x minus 4. So again we have to manipulate it so as to, what our aim is to get x terms on the one side and to get all other terms on the second side. So what I am going to do, I am going to take this x here and this 4 here, so it becomes 4 minus 3 greater than 2x minus x. So this becomes 1 greater than x. So what this inequality is saying? This inequality is saying that x should be less than 1. X should be less than 1. That means the set of values that will satisfy is minus infinity to 1. Again we cannot include 1 because there is no equal to sign. So minus infinity to 1. This is our answer. Now we'll move to the quadratic inequalities. The linear inequalities are a very easy way to solve them, and they are very easy. So the tough part or the good part is quadratic inequality. But before studying quadratic inequality, you have to take care of all the indeterminate forms. For example, in linear inequalities also there are some forms that we need to understand. Now in linear inequality there is one rule, and that rule is, suppose that if it is written like this, that 1 upon x minus 3 must be greater than 0. Now obviously you want that multiply this x minus 3 0 here. That cannot happen because we are multiplying a factor with 0. So what we are going to do is that we are going to take the inverse. Okay. If we are going to take the inverse, then this x minus 3 will come in the numerator, but this sign will change. The sign will change. Okay. So if the sign changes, that means x must be less than 3. Okay. If the sign changes, then x must be less than 3. Okay. Now but if you are doing this, then you have to satisfy. Whatever things you are doing, you have to satisfy. So if you are doing like this, which is a general misconception that if you do it, it will change sign. No, this is not the correct way. The correct method is to multiply and divide numerator and denominator by x minus 3. So it will become like this. Now we have to take care about few things. First of all, this x minus 3 whole square is always positive, so we don't have to worry about this. Okay, the one thing that it is giving is that x cannot be equal to 3. Why? Because if x becomes 3, then this function becomes undefined, because it will come as infinite. So x cannot be equal to 3. This is the result given by the denominator. Now if you look at the numerator, now we can take the numerator separately. So x greater than 3. Now obviously x cannot be equal to 3 and x greater than 3. That means all the values that we are looking for are 3 to infinity. Now you can put any of the values from here. It will satisfy you. Obviously x cannot be less than 3, because if it becomes less than 3, then there is a negative sign. So this negative sign will make this whole thing less than 0. So we cannot take x less than 3. So this is the answer. This is the way to solve. Now let's move. Moving on to quadratic inequalities. Quadratic inequalities. Suppose there is a quadratic equation written like this. Now, if this is the quadratic equation and we want it to be greater than 0, we know that the graph of quadratic equation, if it has two roots, then it will be something like this. This will be one root and this will be the root. So, if we want greater than 0, that means we require all the area that is above the x-axis. We want all this area. This area deals with greater than 0. Similarly, at the same time, if we want our inequality to be less than 0, then we want this area less than 0. What you can do, you can term it as y. This is y. So y greater than 0, that means all this area, red one. And y less than 0, that means the area that is below the y-axis, below the x-axis. But again, how to get it mathematically? Well, to get it mathematically, the very basic thing that we need to do is that first factorize the quadratic. Now, if I go to factorize the quadratic, that means x square minus, I can write 5 as 3 plus 2, okay, and then x, and then I can write 6 as plus minus 3 minus 2 greater than 0. So if I do the factors, then the factors are x minus 3, x minus 2 greater than 0. Now again, there are two factors. So how to solve this inequality? In order to solve this inequalities, there is a term that we call as wavy curve method or snake method. Here you have to draw a curve that looks like a snake, so that's why it is called as wavy curve or the snake method. Now let's see how to solve it. First of all, what you need to do is that draw the number line. This is a number line. Plot the roots. What are the roots? X minus 2 is equal to 0, so x equal to 2 is the root. Similarly, x equal to 3 is the root. So plot the roots. So this is 2, this is 3. Now we have to draw the curve. How to draw the curve? Take any point either on the extreme left or either on the extreme right. So suppose I take a point on extreme left, suppose I take x equal to 0. Now why I am taking this point? Because I want to know that what is the sign of function at this point. What do I mean by sign? By sign I mean that how the function is behaving. Is the function positive or negative? So if I put x equal to 0 here, then minus 3 into minus 2 will be plus 6. That means at x equal to 0 the function is positive. If the function is positive, then my graph would start like this. That means that before this x equal to 2, that means on the left hand side of x equal to 2, all the values are positive. If you put any point before x equal to 2 or on the left hand side of x equal to 2, all will give you a positive outcome. You can try and put any value. Suppose let's say put minus 10, minus 30 and minus 12. That means plus 130, plus whatever thing. So before this point, all the values are positive. Now, when you encounter a root, whenever there is a root, you have to change the sign. Whenever there is a root, you have to change the sign. That means what? I was here, now I will go like this. Again now there is a root, so I will change sign. That means all this area is positive. You can take any value and all these values will give you a positive outcome. Any of these values will give you a negative outcome. Any of these values will again give you a positive outcome. Now what do we want? We want our greater than 0. We want our equation to be greater than 0. That means we want them to be positive. So if you want them to be positive, then our answer is this whole area. So the answer is minus infinity to 2 union 3 to infinity. Remember that this is the negative area, so we are not including it, and except this, both the areas we have to include, each and every value. Now we cannot include 2 and 3 because at 2 and 3 the function will become 0, but we want greater than 0, so we cannot even include 2 and 3. Now let's take some other cases. Let's take the case of repeated roots. Suppose that I have a quadratic equation like this: x minus 3 x square minus 2x plus 1. I want it to be greater than 0. So again, this is a quadratic. First, my basic aim is to factorize all the quadratic equations into factors: cubic, quadratic, biquadratic. If there is any equation like this, then I want to factorize it first. So what are the factors here? X minus 3 is a factor in itself. This is actually x minus 1 whole square greater than 0. Now what you have to think is that what is happening here? X minus 3, there are two factors at 1, x minus 1, x minus 1. So look how these two factors are going to behave. If I draw my number line, okay, there are x equal to 3 and x equal to 1. Again, our previous method, check the sign on extreme left or extreme right. So on the extreme left, let's say 0, at 0 the sign is negative. So I am coming from downwards. I am coming from negative side because the sign is negative. So here I am coming from negative side. I encountered the first root. So I have to actually change the sign. But I encounter another root. There are two roots at 1. If there is one root, suppose we are coming from negative side. If there is one root, then I will change my sign from negative to positive. But there is another root. So from this positive, I will again change my sign. Because there are two roots, so you have to change the sign 2 times. That means negative to positive and then positive to negative. That means if there are two roots, then we remain at the negative side. If there are two roots, then we are on the same side. So again a thumb rule that if you have even roots, even number of roots at the same point, then no sign change. But if you have odd number of roots at the same point, then sign change. Just the basic rule. Even number of roots, no sign change. Odd number of roots, sign change. So there are even number of roots at 1, so I am not going to change my sign. So I will rebound back. Now I come to 3. At 3 there is one root, so I will change sign. So what my areas are depicting? All this area is a negative area. This is again a negative area. But this area here is positive. So what is my answer? My answer now becomes, I need to take positive area, that means 3 to infinity. If someone asks me for the answer for less than 0, what I am going to say? Minus infinity to 1 union 1 to 3. Why I am writing this? Because 1 is not included. At 1 the value is 0. You can also try and put x equal to 1 here. The value is 0. Or I can write it like this as well. Except 1. So there are different ways, but you have to remember repeated roots case. This is the repeated roots case. Now let's take one last example. Okay. Suppose that you have a polynomial in p by q form, where p is also a polynomial and q is also a polynomial. Now how to do this? P by q form, let's say x minus 3 x square minus 8x plus 15 divided by x plus 5 and x square minus 5x plus 6. We want it to be, let's say, greater than or equal to 0. Now again, the first thing is that we are going to factorize it. So let's factorize x minus 3. I can see that this is nothing but x minus 5, x minus 3. Okay, let's take it like x minus 5 so that our questions become interesting. Divided by x minus 5. This is what? This is x minus 3, x minus 2. Now look what is happening. There are 3 roots and x equal to 3, and there are 2 roots and x equal to 5. If you are trying to do this, that let's cancel this and this, and let's cancel this and this, then you are doing it wrong. This is wrong. You cannot do this. If you are doing this, that means you are cancelling a root. You are cancelling a factor. If you are cancelling a factor, then it can have effect on your answer. So you cannot cancel the roots. You cannot cancel the roots. That is the basic thing. You cannot cancel the roots. Now look, if we want it to be greater than 0, then first let's take at how many, at x equal to 2, how many roots are there? At x equal to 2, there is 1 root. At x equal to 3, there is 1, 2 and 3 roots. So x equal to 2, 3, there are 3 roots. X equal to 5, there is only 1 root, 2 roots. X equal to 5, 2 roots. So sign change, no sign change. Or at odd roots we will change sign, at even roots we are not going to change sign. Let's take it as, yeah, we want it to be greater than or equal to 0, okay. So number line 2, 3 and 5. 2, 3, 5. Observe the sign at x equal to 0. At x equal to 0, negative, 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 negative. That means 6 negatives, that means positive. So we are going to come from the above side. At x equal to 2, there is only 1 root. So we are going to change sign. At x equal to 3, there are again odd number of roots, so we are going to change sign. At x equal to 5, there are even number of roots, so we are going to rebound back. Okay, x equal to 5 as a rebound. Positive area, negative area, positive area, positive area. We want greater than or equal to 0. So actually our answer is minus infinity to 2 union 3 to 5 union 5 to infinity. Now I haven't applied the brackets because in order to apply the brackets we need to think that what is the behavior. So from minus infinity to 2, that means minus infinity is obviously not included and this infinity is obviously not included. At x equal to 2, we cannot put value x equal to 2 because this will become 0 and the whole function will become infinity. So we cannot include x equal to 2. Similarly, we cannot include x equal to 3 as well and we cannot include x equals to 5 as well. So 3 is also not included, 5 is also not included. So that means that my answer is minus infinity to 2 union 3 to infinity minus 5. So this is the answer.